Hello guys, and welcome to my YouTube channel. In this video we are going to I'm going to show you how you can identify the charging IC without a schematic diagram. Sorry. How you can identify the charging IC without a schematic diagram. So I'm going to use two PCB, one with the bigger charging IC, one with the bigger charging IC, and the other one with a small charging IC. As you can see, this PCB, this is the charging IC. This is the charging IC of this motherboard. And then this is the charging IC of this motherboard, as you can see. Okay, I'm going to show you how you can identify the charging IC and also what are the differences between this bigger charging IC and the smaller one. First of all, what you have to know is that phone motherboards are divided into different sections. You have the network. So when you check carefully, you'll see the network section. You see that in this section, you don't have bigger capacitors like you have them in the power section. So this is the network section. Why? Because you see the antenna. And then you see that there are no bigger capacitors in the network section. You see, if I take this other PCB, it's the same thing. You see that this is the network section because there are no bigger capacitors here. And then you see the antenna. You see. Now, the other side, which is the power section, as the name implies, power section, you see the capacitors and inductors. For example, this is the power IC. You see inductors, capacitors, there are so many because it is the power section and this with voltages. If I take this other PCB, you also see it here. You see, this is the power section. This is the power IC. This is the charging IC. Okay, how did I know that this is the charging IC? Because if you check carefully, you see that the charging IC is almost like the power IC. The power IC has many inductors and capacitors around it, and the charging IC is also like the power IC. You see that you have one inductor and then you have several capacitors around it. You see, they almost look alike. So that the bigger charging IC in this motherboard has only one inductor. When you check every bigger charging IC, you see that they have the one inductor. If I come here, you see that this is the bigger charging IC on this motherboard. You see I have only one inductor. You see, only one inductor. Is it? But why on the smaller one, you don't have any inductor. You see, what you see here is a resistor. What do you see is a resistor. So in a smaller charging IC, you always see the resistor, which is the output voltage, where the voltage goes to the battery connector. So you always see the smaller IC, you always see the resistor, while in the bigger charging IC, you always see the inductor and several capacitors around it, as you see. So you can see the difference. Why this one, it has different function. The bigger charging IC, it has different function. For example, when it gets the input voltage, it's going to produce two voltages. One that passes through this coil and goes to the power IC, the backlight IC, and the other one that passes through like you can see that here you have a diode. So the other one will pass through maybe the diode and goes to your battery connector. So it produces two voltage. It has several functions. While the smaller one has only one function. What it does, it only takes the voltage from this capacitor into the IC, and then passes it through the resistor to your battery connector. So the voltage, it only produces one voltage that passes through this resistor to your battery connector, unlike the bigger one that produces two voltages. So how can you know that this is a charging IC if you don't have a schematic diagram? So like I said, the charging IC is always found at the power section. It's found at the power section, like you see here. This is a charging IC. It's on the power section. If you don't see it here, close to the power IC, you can also see it behind. This section is a processing section. A processing section. You have the CPU and the eMMC. So you don't see it here. Close to the power IC, you can also see it behind. Like for example, this one. You see that this one is behind. Close to the processing section is behind. Where the power IC is here. So if you don't see it here, you can find it behind. Okay, now how can you identify the charging section, the charging IC? So what you can do is, like I said, where you have to check it at the power section. Yeah, if you don't see it here, like on this motherboard, if you don't see it here, then you can check it behind. Now, the charging IC, you always see a coil, a bigger coil, one big coil. You always see it. Now, what you do is, you are going to take your multimeter. For you to identify it without a schematic diagram, you will need a multimeter. And then you place the multimeter on booster mode. And then you are going to use one end. This coil that you see here, takes the voltage from the charging IC and then brings it to the power IC. So for you to know that that is a charging IC, you can put your multimeter on booster mode, put one end. You are going to put one end on this inductor and then the other end. And then you are going to bring the other end. Bring the other end and put it on this capacitor. This is the positive side of this capacitor. As you can see, you can hear the beep. You see? It means that this point is connected to that inductor. You see, when you hear the beep, it means that they are connected. It means that there's a continuity. This inductor is connected to these capacitors that are here because that is the inductor that brings the voltage for the power IC through these capacitors. So that is why you have that connection, that beep. It means that this is the charging IC. Now, you can also know it by taking the reading, the diode reading. If I take the diode reading of this inductor, can you see the diode reading? You see that giving us 293 or 292. If I check it here, this capacitors here, you see that 293. So it means that if you see that the reading are the same, the diode reading are the same, means that those points are connected. So it means that this is the charging IC. This is the charging IC. They have the same reading. So you can know the charging IC through that method. But you can also know it by what you can also do is you can put your multimeter on one end on the positive side of this battery connector. You put one end on the positive side of the battery connector. Show it clearly. One end on this positive side of the battery connector, and then you use the other end to test this capacitor. For example, let's check and see which part is connected. Okay, Okay, let me see. In order not to waste your time, let's see, it's giving us 322. That's the positive side of the battery connector. It's giving us 322. Let's see the capacitor that will give the same reading. This one here are short. Okay, 25. 324. Well, in order not to waste your time, so you can also do it that way. 317. 317. You can also do it that way. You can also check the reading of this capacitor. And if you see that there's any capacitor that gives the same reading, 316, this should be the point. 316. This should be the point. 316, you see. It's giving us 316. 316. So those points are connected. So you see that this capacitor is connected to the battery connector. So that's another way you can check it. So you can check the connection, put your multimeter on the positive side of this battery connector, and then one end you're going to test. You're going to test that section. If you hear a beep, it means that they are connected. In this smaller charging IC, you also do the same thing. Like I said, in order to identify the charging IC, in this smaller charging IC or this motherboard, you always see the resistor. You always see the resistor. Unlike the other one, unlike this one, you see an inductor and several capacitors around it, or a diode. You can see the diode is there. That diode takes the voltage to the battery connector, while this one takes the voltage to the power IC, backlight IC, and so on. So this one is a smaller charging IC. You always see that a resistor. You see that there are smaller capacitors around here that brings the voltage into the IC, from the IC to this resistor. So how do I know that this is a charging IC? What you have to do is you are going to put your multimeter to booster mode, and then you are going to place one end on this resistor, and then you place the other end to the battery connector. That's it. You see, it means that this point is connected to that resistor, which is this is the positive side of the battery connector. So it's connected to this resistor. You can also see that they have the same value. You see, 301 or 2, 301 or 2, you see, that they are connected. So you can test it by checking the reading. If you see that the reading is the same, by checking the reading, if you see that the reading is the same, means that those points are connected. That is the charging IC. Because from here, the voltage comes to the positive side of the battery connector. So I hope everything I said is understood. So you see that the bigger charging IC has several functions, unlike the smaller one that has maybe one function, just by taking the voltage to the battery connector. While this one brings two voltages. One goes to from this inductor goes to the power IC backlight graphics, while the other one comes through these capacitors or this diode to the battery connector. I hope everything I said is understood. So you see that this one, you always see a resistor. The resistor is there to prevent voltage fluctuation, or to prevent voltage, like for voltage to flow and cause damage to the battery connector or to the battery, in order to prevent spike, like fire spike. So that's why the resistor is there to prevent that to happen. So I hope everything I said is understood, how you can identify the charging IC without a schematic diagram. So first, like I said, you have to check it on the power section. And then second, what you can do is, if you see a charging an IC that looks like the power IC, if you already identify the power IC like this, then you have to look for the one that looks like this one, almost like this one. You see the inductor, you see the capacitors. So what you can do is, you take your multimeter, you place one end on this inductor, and then you place the other end on this capacitor. These capacitors that are at the middle of this IC, the power IC, and the inductors. So this one here, if I show you this other mod, it's the same thing. This motherboard is the same thing. You see the capacitors there at the middle between the inductor and the IC. You can see. So you take your multimeter, then check it from there, put one end here, and then touch one end here. You see that there's a connection. You can also know by the value. If you measure the diode value from here, and then you come and measure the diode value from here, if they are the same, it means that this is the charging IC. Another way to know is to put your multimeter on this point, the positive side of this battery connector, and then use the one end to test. You are going to see that there's a capacitor that is connected to this battery connector, and if you hear the beep, it means they are connected. Or what you can also do is find the reading by use a multimeter to get the reading, and then come and check the other reading from here. If they are the same, then that is a charging IC. On the smaller motherboard, like I said, you always see a resistor. So if you see the resistor, from that resistor, you can put your multimeter, place it there, and then use the one end to touch it. If there's a continuity, then that is the charging IC. You can also know by the reading. If you get the reading here, you come here and also get the same reading, it means that this is the charging IC, they are connected. So I hope everything I said is understood. Well, if there's something you don't understand, you can send me a message on the comment section, and I'm going to explain. Please like my videos and subscribe to my channel if this video helps you to understand something. And also, for more interesting videos to come. Thank you very much.